Hi students, good morning everyone. Welcome back to today's class. In our previous class, we have started a next topic in our unit 2, that is measures of dispersion. So what is measure of dispersion? Before that, what is a dispersion? Dispersion literally means the scatteredness. How the points are distributed are called scatteredness. So how to study the scatteredness? By using the measures of dispersion. So since measures of central tendency does not provide the complete information about any distribution. It just says about the values in the central part of the distribution by a single value. So that is not at all enough to know about or have an idea about any distribution. So that's why we use measures of dispersion also in addition to the measures of central tendency to have a clear idea about the distribution. That means in any distribution how the points are distributed, that is very close or they are scattered, can be known by using the measures of dispersion. So always there should be less variation in your data. So the less variation in the data gives the good results. So if the points are scattered so much or they are heterogeneous, the results will not be much appropriate. That means not much appropriate, but it is not considered much. Whenever you compare two data series, so whichever data set is having the less variation, that is considered as the best data set. So that's why the measures of dispersion helps to know the variation in the data, that means the scatteredness in our points. So there are 4 measures of dispersion, right? What are the 4 measures of dispersion? First one is range, next quartile deviation, and the third one is mean deviation, and the last fourth one is standard deviation. So in the last class we have seen what are the different characteristics of an ideal measures of dispersion. So today we will start with the first measure of dispersion and check out what all the characteristics it satisfies. So coming to the first measure of dispersion is range. So what is range? We know range means the difference between the highest value and the lowest values. So whenever you have some points in the distribution, that highest and lowest values are called as the extreme values. So extreme values means which are in the corners, that is extremes. So left side, if I arrange the data in an ascending order, the left side you will be getting the least value, and on the right side you will be getting the highest value. So those are the two extremes, right? So extremes means the lower limit and the upper limit. So range is defined as the difference between the two extreme values. The difference between the extreme values of a distribution. Or you can write it as the difference between the maximum and the minimum value, or the difference between the highest or the difference between highest and the lowest values of any distribution in our data set. Highest and the lowest values. So lowest values or highest or the lowest observations in the data. So in our data, by considering the highest and the lowest values, we will be drawing the range value. So what is the formula for value, and similarly SAC minimum or the smallest value. So in any data set, if L is the maximum value and S is the minimum value, then range equals to, what is generally range? Maximum value minus minimum value, that is maximum value is L, so L minus minimum value is S. So the formula for finding the range is L minus S. Now we'll consider a small example. So for the given data, suppose I am giving the values as 7, 9, 15, 14, 6, 8. So for these given values, find the range value. So what is the maximum value? So here maximum value is denoted with L according to our formula. So L equals to, what is the maximum value? 15, and S equals to the smallest value. What is the smallest value here? 6. So what is the range formula? The range is equals to L minus S. Now substitute the L and S values. So if you substitute L value, what is the L value here? 15 minus smallest value is 6. So 15 minus 6 is 9. So therefore the range is equals to 9 for this given data. So in this way we will be finding the range value. So I will give a small example for you. Find the range for the given data. Find the range for the given data. So I am giving the data as, so the data is 4, 8, 12, 3, 7, 13, 18, 1. So for this, not 1, 17. So for this data, find out the range value. So it is very simple. Just choose the highest value minus the lowest value. You will be getting the range value. Now we'll see the different merits and demerits of the range. So we'll see how many characteristics of a good measures of dispersion does this range satisfy. So coming to the merits. So the first merit is, we know it is very simple to understand, right? So it is very simple to understand. So there is nothing in this range, just the difference between the largest value and the smallest value. So it is very simple to understand. In the same way, it is very easy to calculate. It is easy to calculate. So no complicated calculations are involved in this calculation of the range. Only the highest value minus the lowest value, you will be getting in forecasting, price analysis and also the quality control, the range is used. So these are the different merits of the range. Now we will see the demerits. So coming to the demerits, it is based on only two observations. The first demerit is, it is based on only two observations. So we have seen in the characteristics that whatever the measure is there, that should be based on all observations. But here we are finding the range only by using the maximum and the minimum values. So that's why it is a drawback that it is based on only two observations. Next is, it cannot be calculated for open-end calculators, open-end classes. It cannot be calculated for open-end classes. So we have seen in the measures of central tendency also, few measures are not calculated for the open-end classes and few measures are calculated for even open-end classes. So what are open-end classes? Suppose if you have a class interval 0 to 10, 10 to 20, 20 to 30 and the corresponding frequencies. So here if you observe the first class frequency, the lowest value, is it having a closed interval 0 to 10, a particular value is there, and even the last class interval 0 to 30, the limit is there. But if you observe this example, so here I am writing the class interval as below 20, 20 to 30, 30 to 40, and the last I am writing as above 40. So if you observe here, the first class interval is having any lower limit? No. And the last class interval, does it have any upper limit? No. So if the first, either the first interval is not having the lower limit or the last class interval is not having the upper limit, that are called as the open-end classes. So the limit is open here, below 20. So here 0 to 10, 10 to 20, here 0 to 10. The values are from 0 to 10 only. So here what is Q1? Where Q1 is the first quartile and similarly what is Q3? Q3 is the third quartile. So first quartile is called as the lower quartile and the third quartile is called as the upper quartile. Since we will be having 3 quartiles, Q1 is considered as the lower quartile and Q3 is considered as the upper quartile. So the difference between two quartiles means Q3 minus Q1. Quartile deviation means half of the difference. So quartile deviation, it is denoted with QD, such that QD equals to Q3 minus Q1 by 2. So quartiles, for quartile deviations, first we need to calculate the quartiles. So quartiles can be calculated depending on the data. If it is ungrouped data, the quartiles are calculated as first Q1 is n plus 1 by 4th term in the ascending order. Similarly, Q3 is the 3 into n plus 1 by 4th term in the ascending order. So by considering Q1 and Q3 values and substituting in the quartile deviation formula, we will be getting the quartile deviation for the ungrouped data. So in the next class, we will be seeing the